Now we are coming back to the main experimenting program Cask Hydro Point M. We already described this program in a previous video. We explained how we record the process reaction curve. We also explained how we perform oscillating experiment. These are two experiments from which we calculate the parameters of PID controllers using so-called first and second Ziegler-Nichols method. In this part of the program, we shall compare simulation results using P, PI, and PID controllers with Ziegler-Nichols rules, and also these results will be compared with the controller obtained with optimization. So we shall compare the results obtained for reference tracking mode and disturbance rejection. Let's start with reference tracking mode using the first Ziegler-Nichols method. This is method which is based on the reaction curve. I shall open this table. So, in this part of the MATLAB program, we develop P controller. This is the equation, how we calculate the Kp parameter. This is actually the expression from this table. To remember, with process reaction curve, we obtained so-called lag or delay time and rise time. Then we calculate PI controller from this equation and PID controller from this equation. After we calculate the controller parameters, we use sim function in all these cases and also plot the results. As we use hold on command, these plot statements will plot in the same window. Then we also simulate the situation with optimized PID controller. I shall open another table. This table was obtained with optimization. For the reference tracking mode, we obtain these three parameters of the PID controller. These are these parameters, and we again simulate this situation, and then we also plot the simulation results using optimal PID controller. Now I shall select the whole program. So this is appropriate selection, F9, and I obtain in this window simulation results. I can see the results for the reference tracking mode using P, PI, and PID controllers. All these controllers were calculated from Ziegler-Nichols 1 method, and with red color denotes the solution when we are using the optimized PID controller. So what can we notice in general? That the blue curve shows the steady state error, then PI controller, this is this black curve, it doesn't have the steady state error, but due to E part the response has strong oscillations. When we are using PID control, this is green curve, the oscillations are a little bit damped, but all these responses show rather big oscillations. So the red curve shows the optimized PID controller, which is, of course, the best. Let's continue with the second Ziegler-Nichols method, which is based on oscillating experiment. Let's continue with this program. So I will open another table. So in this part we calculate P controller from the parameters K critical. Then we calculate PI controller. In these equations we also need, beside critical gain, also critical period. And this is PID controller, which is calculated with this row in the table. So again, we need critical gain and critical period. And the PID controller obtained with optimization is the same as before. And so I will select now this part of the program. F9, and we obtain simulation results using the parameters on the basis on oscillating experiment. The results are very similar to the results using process reaction curve. This blue curve is connected with P controller. We can see the steady state error, then PI controller with the black curve, PID controller with the green curve, and the best results are again obtained with optimized PID controller, which is depicted with red color. In this part of the program, we develop the analyze for disturbance rejection mode. So in this case, we put the constant reference equals 0 and Z equals 0.5. This means the reference signal is 0 and the disturbance signal is 0.5. We calculate PPI and PID controllers just the same as for the reference tracking mode, because Ziegler-Nichols rules do not distinguish between reference tracking mode and disturbance rejection mode. So P, PI and PID controllers are the same as before, but the PID controller obtained with optimization is different in this case. Let's see this table, which has two rows. In the previous study, we used these parameters of the PID controller, but in the case of disturbance rejection mode, we now use these three parameters. These are these three parameters, and of course for each situation we simulate the Simulink scheme. Let's select this part of the program. F9. So These are simulation results using disturbance rejection mode of the controller and also using the Ziegler-Nichols first method and of course the optimization method. So again, we have here with blue color the results of P controller. There is a steady state error. Then with black we have PI controller, with the green PID controller, and the best rejection of the disturbance is obtained with optimized PID controller. We can notice that this controller rejects the disturbance in about 40 minutes. Then we continue the comparison of simulation results using this time Ziegler-Nichols second method. This is oscillation method. Again, the PI and PID controllers are calculated the same as in the case of reference tracking mode, and PID controller was obtained with optimization. So I will select this part of the program. And these are simulation results. Again, rather similar to the results obtained with Ziegler-Nichols first method. This blue curve is the P controller with steady state error. The black PI controller, very oscillating response. Then PID controller. The deep part introduces additional damping, and the optimal or optimized PID controller, which performs the best behavior.